Hello, 7th graders. We are in section 6.2. Now, in section 6.2, we're going to talk about multiple representations of slope-intercept form. Now, if we are talking about multiple representations of slope-intercept form, we're going to take what you already learned last year, and I know you all know what slope-intercept form is. However, we're going to take it one step further this year and talk about domain and range within slope-intercept form. Now, you do not need to write all of this down, absolutely not, but I will tell you what you do need to write down. In section 5.5, you studied direct variation. Now, if you look at direct variation, an example here would be y equals 3x. The graph of a direct variation is a straight line. All direct variations are linear functions. That means they are functions that make a straight line. So a linear function, this is what you do need to write down. A linear function is a function that graphs a line. Direct variations are only part of the family of linear functions. That's important. Linear functions, a part of that is direct variation. For example, let's look at this equation right here. Y equals negative 1/2 x plus 1. It is a linear function because it does make a line. However, it is not a direct variation because it does not go through the point 0, 0. Now, a parent function, which I've kind of talked to you a little about, a parent function is the simplest equation of a function. Notice it does not say a linear function. As I've already kind of gone over, there are parent functions for quadratic equations, for absolute value equations, and so on. So a parent function is the simplest equation of a function. The equation, make sure you memorize this. The equation y equals x and f of x equals x is called the linear parent function. Now the linear parent function is going to be y equals or f of x equals x. A linear equation is an equation that models a linear function. A linear equation is an equation that models the linear function. So you need to write down all those vocab words. In a linear equation, the variable cannot be raised to a power other than 1. So notice here, for example, if we look at this equation, the highest power on your variable is 1. Here, y equals 2x. It has a power of 1. But if you look at y equals x squared, that's not a linear function because that has a power of 2. Y equals 2 to the x, that has a power of x. So that does not work. Now looking at your graph over here, notice these are all linear functions. Now only y equals 3x here and y equals x, those are direct variation. Y equals x is your parent function. So you do not need to draw this. You don't need to draw any of this down right here or the table. But there is something I want you to notice. The equation of a line gives important information about its graph. Consider the table and graph below. So you'll notice, which you can do this, if you drew a t-table and you picked 0, 1, and 2 for x, you would get 1, -1, and -3 for y. So your domains are x, your y's are your range. Notice this. This is what's going to be maybe a little different than what you've learned in the past. Your change in y. What happens from 1 to -1? It goes down 2. What happens from -1 to -3? It goes down 2. This is your change in y. Over here, from 0 to 1, we go up 1. From 1 to 2, we go up 1. So notice that right here, this is your change in x. Your change in y over your change in x. That actually gives you your slope, which you've already learned. Your slope is the variable, the coefficient in front of the variable. So -2 is your coefficient, the variable x, so -2 is your slope. Notice then that positive 1, it's where it crosses the y-axis. So, it's all going to come together. You're going to learn so many parts of a graph that it will all come together in one big cycle where we're going to learn all the different parts of a graph, and no matter if you use a t-table, intercepts, slope-intercept form, it'll all give you the same thing. So let's follow along here. 2 points on this line are 0, 1. I'm going to mark these in red. This is 0, 1. And the other one is 2, negative 3. So you can pick any 2 points on this graph and find the slope. Now the slope, change in y over change in x. Change in y was negative 2. Change in x was 1. Now notice here, we subtracted your y's, which is 1 minus negative 3. That gives us 4. And 0 minus 2 gives us negative 2. So negative 4 halves is negative 2. It is the same thing. They found the distance between the first value here and the last value. The first value and the last value. But if you simplify it, you're going to get the same slope. Now the y-intercept is the y-coordinate of the point where the line crosses the y-axis. Since our equation of y equals negative 2x plus 1 crosses the y-axis at 0, 1, and I'm going to mark that in blue, right there. It crosses the y-axis at 1. Therefore, your y-intercept is 1. If you know the slope of a line and its y-intercept, you can write an equation of the line. The letter m refers to slope. Now, I'm hoping you understand that slope-intercept means that you would find the slope and the y-intercept. All right, so now let's look at your key concepts here. Your key concepts is the definition of slope-intercept. So slope-intercept form of a linear equation. The slope-intercept form of a linear equation is y equals mx plus b. Follow along with me. Y equals mx plus b. Y equals, what is it? Mx plus b. Your m is the slope, that is the coefficient of the variable. The b is your y-intercept, where the line crosses the y-axis. All right, example number 1. This is a multiple choice problem. Which equation models the linear function shown in the graph? Now before we do anything else, we got to use common sense. What is the slope of this line? Now just look at it. Is it positive, negative, 0, or undefined? This graph goes downhill. Therefore, the slope has to be negative. We then instantly know that C and D cannot be our answer, because if you look at C, 2x minus 4/3 x is going to give you a positive slope, and this one is just 2, so the slope is 2. Well, it's also positive, so therefore it can't be our graph. So now, let's just look at where it crosses the y-axis. Where does this red line cross the y-axis? Right there, at 0, 2. Therefore, our y-intercept is 2. So we know we're going to have a plus 2 at the end of our graph. Now our slope. Here's what you need to do to find slope. You pick any 2 points on this line. So here, I found one right there, 0, 2. And let's find another one. Oh, here's one. 2, 3, 4. That'd be 4, negative 1. Find the slope. Let's subtract your y values. That'd be 2 minus negative 1. Subtract your x values, 0 minus 4. So that would give us positive 3 over negative 4, which would give us a slope of negative 3/4. Therefore, our equation would be A, y equals negative 3/4 x plus 2. Remember, the top number is going to tell you to go up or down from one point to the next. The bottom number will tell you to go right or left. So if I start here and I go down to the right, down to the right, down, 1, 2, 3, that'd be a slope of negative 3 for the change in y. A run or change in x, 1, 2, 3, 4, down 3, right 4, gives me a slope of negative 3/4. So let's write an equation for this line. Remember, y equals mx plus b. What does the m stand for? Good, that's your slope. What does your b stand for? Good, y-intercept. But what does the y-intercept mean? Where it crosses the y-axis. So that's what I always would start at. I always start at where it crosses the y-axis. So where does this graph right here cross the y-axis? At 0, 1. So we would know that the y-intercept is plus 1. Now to find the slope. Find any other point on that line. Now if I look at it, I see one here, I see one here. It doesn't matter what you need. So if you use 2, 2, that means I have 2 points, 2, 2, 0, 1. I want to know for slope, change in y, change in x. So change in y. What happens from 2 to 1? It's going to give us a slope of, or change in y of 1. Then on the bottom, 2 minus 0, that gives me 2. That means my slope is going to be 1/2. And to make sure this works, let's see. Up 1 over 2. Up 1, right 2. Up 1, right 2. Change in y over change in x. Change in y is 1. Change in x is positive 2. Up 1, right 2. My slope is 1/2. Therefore, my equation would be y equals 1/2 x plus 1. All right, this is another thing that a lot of students don't realize. I'm putting a star next to here. Number 1, I like stars. Number 2, it's important. Each point on a graph of an equation is an ordered pair that makes the equation true. Ding, ding, ding. Huge concept here. Any point that you graph that is an ordered pair makes the equation true. You are graphing all of the true points, all put together, that make a line. The graph of a linear equation is a line that indicates all the solutions of the equation. One way to get those points is to use slope and y-intercept. So let's graph linear equations. Now I'm sure you've done this before, but we gotta review it because we want to make sure that we are 100% fluent in doing this. So if we graph the equation y equals 3x minus 1, right off the bat, you should in a split second be able to, bam, tell me, what is the slope? Okay, what is the y-intercept? All right, next question. Does this slope go up or down? Uphill or downhill? Where does it cross the y-axis? Bam, those 4 questions you have to know in an instant. You have to be able to look at an equation, look at a graph, and bam, be able to tell it to me. So, the first thing I always would do, and this is your steps. Step 1, always, always, always start at the y-intercept. Your y-intercept, which is your b, is -1. Your slope is positive 3. But we always want to make sure we write it as a fraction. So the slope would be 3 over 1. Step 1, always start at the y-intercept. The point right here, that's -1. I put a dot. From there, I know my slope is 3 over 1. That means the top number is your change in y. Since it's positive, we go up. The bottom number is positive 1. That means we go right because that's the change in x. So I'm going to go up 3, right 1. Up 3, right 1. I would do it again. Up 3, right 1. You then are going to draw a line that goes through the points with arrows at the end. Top number, you're going to go up and to the right. If it's a negative, you're going to go down and to the right. Let's graph this equation y equals -3/2 x plus 1. Draw a rough graph of this in your notes. Make sure when we always graph, we put arrows on the end of our axes and we label the axis x and the axis y. So step 1, tell me right off the bat, what's my slope? -3/2. What's my y-intercept? 1. You should be able to give me a detailed description what this graph does. Since the slope is -3/2, we know it's going to go downhill. Because my y-intercept is 1, we know that it's going to cross the y-axis. So my y-intercept is 1. I put a dot on 1. My slope is -3/2. From that y-intercept, I go down 3. 1, 2, 3. The bottom number is 2. I go right 2. 1, 2. And I put my point. Down 3. 1, 2, 3. Right 2. 1, 2. I connect it. Therefore, I make a line that goes through those 2 points, and that represents my solution. Now, make a mental note of this. When you graph equations for real-world situations, use scales on the x and y axis that are reasonable for the situation. Recall that you can avoid having a large blank space in a graph by using a zigzag line to show a break in the scale. Here's your break. Let's say that's your x-axis. Bam, we make a break, and that's your y. So if you know you're not going to use like the first 50 points on your y-axis, make a break. Now you cannot make a break in the middle of the line, only at the beginning. All right, this is our last example, and this is a real-world problem. It says that the base pay of a water delivery person is $210 per week. He also earns 20% commission on any sale he makes. Now, I'll tell you right now, on a test or quiz, I would not give you that equation. You would have to come up with it yourself. The equation T equals 210 plus 0.2s relates the total earnings T to sales S. Graph the equation. Step 1, I'm going to move it so it's in slope-intercept form. What's your slope? It's 0.2. What's your y-intercept? It's 210. Now, if you think about it, we're going to start our graph on 210, and then we're going to go up 0.2, and then we're going to go over to the right. But we got to be careful here. If I draw my graph, my x-axis, we can have it go by whatever you want. But we notice that this is going to be going up 210. So I'm actually going to skip a whole big chunk, so I don't have to count by 200s. I'm going to skip some. Now notice I graphed this as x. I'm hoping you notice my mistake. There's not an x in this problem. This should actually be S. And what does that stand for? S, it says, stands for sales. And we're talking about dollars. Make sure you always label. This is total. Total what? Total earnings in dollars. Now we know we always start at 0. I'm going to actually put 200. Now I'm not counting by 200. I'm going to count by tens. 210, 220, 230, 240, 250, 260. I'm going to count the bottom by 50. 50, 100, 150, 200. Now, if we graph this, we start at 210. I then have a slope of 0.2. Here's my problem. If you read that, 0.2 equals what? I could go up 0.2 and then over 1, but that wouldn't make sense because I counted by tens. 0.2 would be like barely up. So if you read 0.2, read this as a normal decimal, you'd read it as 2/10. But up 2 is still really small. So I'm going to actually make it bigger. 20/100ths. Well, that makes much more sense. So I can go up 20. So here we go. Up 20. Here's 10. Here's 20. And then I go over 100. 50, 100. So up 1, 2, because that's up 20. Over 100. There's my point. Up 20. Over 100. There's my next point. So I would have a line. Notice that the line does not go to the left because he starts at $210. He's not going to go to the negative side of sales. And for every $200 or every $20 in total earnings, he would have to make $100 in sales.